Okay, guys, let us consider this question paper, which was written in the exams of April. This was April 2024 exams that we are going to consider so that we can see how we're supposed to attempt these typical questions as we are preparing for the exams which are ahead of time. So make sure that you catch up one or two things because in typical or in most cases, they do repeat these typical exam questions. So make sure that you go through, because if there's a difficult question, they have a tendency of taking that question to another exam, meaning to say they can bring a similar question in the next exam. So take note of those questions that you might think that these are difficult as you were approaching them. Those typical questions can be a repetition also. All right, so I'm not going to waste much of your time, guys. I'm going to quickly rush through this question paper, but make sure that you do understand the instructions that you're given. Like here we're given, do all graph work in the answer book, not on graph paper. Take note, guys. Take note. Take note of the instruction that you're given. So you are not gonna, you do not request a graph paper when it is like that, because you are told there that do all graph work in the answer book, not on graph paper. So if they give you that condition, there's no graph paper that you're going to be given. All right. Then round all final answers off to 3 decimal places. So we are going to have 3 decimal places, which is important as part of your instructions. So in this case, we are not going to need any graph in this case. All right, so let's see. Question number one, we are given factorize the following expression in prime factors. These are normal expressions that we are used to, but the way they present now, be like, what is happening here? Okay, let's see. Let's see how we're supposed to factorize this expression. That is 1.1. So actually, there are so many different ways or approach that you can attempt. That is 2a to the exponent of 2 over 5 minus 7a to the exponent of 1 over 5. Sorry for that. That is to the exponent of 1 over 5. So we have this to the exponent of 1 over 5 and also the square root of b plus 3b like this. I want you to remember your quadratic expressions, the ones that you are used to, They are trying to disguise that quadratic expression with these fractions that you are seeing here, and also the square root that we are seeing there. How are they disguising that? Okay. If we are to consider properly, we're going to see that the a to the exponent of 2 over 5 and this a to the exponent of 1 over 5, they have something in similar. Something there in similar. If we are to take a to the exponent of 1 over 5 like this, we raise this to the exponent of 2. We are going to obtain 2 over 5. Remember the exponent, multiply the 2, so that's a to the exponent of 2 over 5. So meaning to say this here can be written as 2a to the exponent of 1 over 5, raised to the exponent of 2. We are just trying to write in terms of this, a to the exponent of 1 over 5. So meaning to say this one is not going to change, just write as it is. We have written the a to the exponent of 2 over 5 that we had in a similar way as a to the exponent of 1 over 5. But look, it is being raised to the exponent of 2. It's a quadratic expression. That's a quadratic, which is just being disguised. They're disguising that quadratic expression. In the same manner with the square root of b and the b there. Okay, let's go back to our algebra. The square root of a squared is equal to what? It is equal to a. The square root of a squared is equal to a. Remember your sets also, they agree with that. The square root of a times the square root of a is equal to a. With this sense, it means the b here can be written as this square root of b. So the square root of b, I'm not going to change it. What I'm going to change is the b to be written as the same way we are having there the square root of b. But how are we going to write it as the square root of b? Square root of a squared is equal to a. So it means the square root of b squared is equal to b. We have written this in terms of what? We have written b in terms of the square root of b. And if you check, it's a quadratic. The square root of b, this is the square root of b squared. So if you are to consider what type of a quadratic, don't worry about this a, whatever that you're given. Don't worry about this. Just put like this. Just so you can even put it this way. Let a to the exponent of 1 over 5 be equal to x, something that you understand. And the square root of b be equal to y. Okay, this is something that you understand. So meaning to say, I'm going to rewrite this as 2 in place of a to the exponent of 1 over 5. I'm having x. So meaning to say, this will be 2x squared. Minus 7 in place of this, remember it's x. What about the square root of b? The square root of b is y. So this is y. Plus 3, the square root of b is y. But this is the square root of b squared. The square root of b squared. So that's 3y squared. Guys, so you tell me you're not used to this expression? No. These are expressions that you have been working with. All our normal factorization has been this. You're used to that. But look how they disguise that. They're trying to hide that from you. So you must be careful in the simplification. Anyways, if you're to consider your factorization, guys, of these quadratic expressions, I don't know which way. Also, watch the grade 9, grade 10 videos on factorization of these quadratic, easier ways that you can actually have on introductions. But in your syllabuses and your textbooks, most of you guys, you apply this. I'm just gonna talk about it, but no problem. If it is the one that you are used to, that part of 2x squared minus 7xy plus 3y squared. Remember, most of you multiply the first term to the last term. So if we multiply the first term to the last term, we are going to obtain 2 times 3, which is 6x squared y squared. So we need 2 terms. We multiply these 2 terms to obtain 6x squared y squared. Add the 2 terms that you multiplied, they must give you the middle term. This term minus 7xy. So which 2 numbers are we talking about? The product. The 2 terms that you multiply, you obtain positive 6x squared y squared. So you think of a negative 6xy and a negative xy. Why are you thinking of a negative? Because the sum, if you add, must be negative 7. Minus 6 minus 1, that is minus 7. If you multiply minus 6 and minus 1, what do you get? A positive 6. So instead of you thinking of 6xy and xy, just put a negative because the middle term is carrying a negative. So for 2 terms to be positive, as their product here to be positive, they both must be negative. Both must be negative so that their product will be a positive. Okay, anyways, guys, this is a normal. a factorization, remember. So you're going to take these two terms into the middle term, then factorize. All right, so that'll be 2x squared minus into the middle term. We're going to substitute these two terms. So we've got minus 6xy minus xy. That one, it's your order. So the factorization thereafter, guys, it's your idea. It's your ways. I do not know which way are you going to do from this part. That one, guys, it's your way. Okay, so if you have to factor out 2x, which is common, that is going to be x minus, divide here, that will be 3y minus y, which is common also, so that this will be the same, positive x minus and minus, that will be a negative, that will be 3y. So this bracket and this bracket, as for me, they are the same. So I'm going to factor out that bracket, take this one into a bracket with minus y. Okay. So maybe this is what you're used to. So like I was saying, the factorization thereafter, it is in your hands. There are actually so many ways. We're going to talk about that, but also make sure that you just watch the videos on factorization, this and that. So this part here was going to give us two brackets. So with someone, you do not even need this by side. By just studying these numbers, you can even tell what is happening. So that's 2x minus y into x minus 3y, or x minus 3y, no matter the order that you want there. So this is not our answer, this one. It is the answer to this part we introduced, which was not part of our question. Remember, that's why we said let this be equal to. Let. We are introducing something which is not part of our question. So therefore, what will be our answer? Our answer now, we are going to substitute what we introduced. I mean, we are going to remove what we introduced in place of the original terms that were there on our question. So meaning to say 2x. What is x? A to the exponent of 1 over 5. Minus y. What is y? Y is equal to the square root of b. Into another bracket, we've got x. X being a to the exponent of 1 over 5 minus 3y, and y is the square root of b. Just like that. Just like that. So there are so many ways the factor. So that's why you see actually it's 2 marks, and you'll be wondering, like, why 2 marks? Okay, I do not want to confuse you. Can you keep on with the factorization that you are used to? At least the idea of the introduction of the those other variables is important, but to the factorization, maintain that what you do understand. 1.2, determine the value of a factor and remainder theorem. We talked about that as an introduction. Make sure that you do watch that video where we are given determine the value of a if f of x is equal to this, gives a remainder of, if divided by, for x minus 3, for x minus 1. I said, guys, as long as you're dealing or working with the factor and remainder theorem, it is one thing that you just need to understand. What is it that you're going to need? Okay, 1.2, let us take what we are given. So on 1.2, we are given to find the value of a, meaning to say we do not know the value of a, given that our f of x was equal to 8x to the exponent of 3 plus 4x squared plus ax plus 3. And we are told that it gives a remainder. Gives a remainder of, we are given a remainder if divided by 4x minus 1. So we are given the remainder in this case, which is 1 over 4. When divided by what? When this is being divided by 4x minus 1. Okay. So let's get back to the statement that you are given, guys. It's very easy to attempt this question. You just need to know this. For what is dividing It is the one that you focus with. Like I said before, what is the value of x from there? Whether they said it is a factor, whether you are given a remainder, you focus on what is divided by 4x minus 1. So you let that to be equal to 0. Let 4x minus 1 to be equal to 0. You calculate your x. So meaning to say x is equal to 1 over 4. X from this is just a coincidence that these values are the same. This is not the one that you're seeing there. No. Just by coincidence, if it was divided by 3x minus 1, it means your x was going to be 1 over 3. It was not going to be 1 over 4. So this one, it is just by coincidence that these two are the same. The 1 over 4, the 1 over 4, the value of x, and the 1 over 4, our remainder. So do not confuse that. Okay, so this is it. From the value of x that you have determined, if they are referring to a remainder, therefore, the f of x that you are given, which is the f of 1 over 4, must be equal to the remainder. That is the idea. So if it was a factor, what was I going to do? If they say this here is a factor, which means there's no remainder, it means the f of 1 over 4 that I calculated here was supposed to be equal to 0, because when there's a factor, there is no remainder. The remainder is 0. But always f of that x that you calculated is equal to the remainder. So if there's if it is a factor, it means there is no remainder. So that's why we equate to 0. But in this case, we are not going to equate to 0 because we have the remainder. Our remainder is 1 over 4. So it means that f of 1 over 4, which is the x value that we are having here, must be equal to 1 over 4, which is our remainder. So what does this part mean? It means wherever there is x, f of 1 over 4, it means wherever there is x. Wherever, remember it was f of x before. So wherever there is x, we are going to substitute 1 over 4. Wherever there is x in this expression, we are going to substitute 1 over 4. So let's solve. Okay, so we are going to obtain 8 into x, which is 1 over 4 to the exponent of 3. So remember, substitute your x there, plus 4 into x. Our x is 1 over 4 to the exponent of 2 plus ax. So remember, our x is 1 over 4. So that's 1 over 4 times a plus 3. We do not have x there. So this is equal. This is our, this part here. This is your f of x, this one. That is your f of 1 over 4, this one. Substituting 1 over 4 in place of f of x. But after substituting, we are saying it must be equal to the remainder. And our remainder is what? Is 1 over 4 according to what we are given there. So it is an equation now that you have solved, that you have created. Forget about factor and remainder theorem now. This is an equation to be solved, a normal equation. So how do I go about it? Combine the terms. As you can see, we have got these terms which are just normal values. This one can be added to this one, can be added to 3. We do not have a, so use your calculator to simplify those terms combined. So combine this term, and 3 together. That is the idea. So if you combine, if you're to combine these, you're going to obtain 27 over 8. So that's 27 over 8 plus 1 over 4a. Remember, there's a 1 over 4a here, which is equal to 1 over 4. All right. This is a normal equation, guys, that you're just solving. So you can even transpose the 27 over 8 to the other side of the equation so that it will be a negative. So 1 over 4a is equal to 27 over 8 subtracted from that side. It was going to give us negative 25 over 4. All right. So that's it. So to determine a, it's either you're going to divide by 1 over 4. The guy is this one. It's up to you. You can even divide by 1 over 4. So a was going to be negative 25 over 2. Or you can even do this way, 1 over 4a is equal to minus 25 over 4. So as you can see, guys, the denominators are the same. Are they the same here? No, this was negative 25 over 4. All right, guys. There is a value that I did write wrongly here. This is 25 over 8. Wondering to say, why is it different from what I'm having here? So that'll be something like this. All right. So it was supposed to be like this. So if you're to consider in this case, that was a 4 and that is an 8. So how do I get rid of this 4 in the denominator? I can just multiply by 4, multiply by 4. So that is it. So a is equal to, if we multiply these two, that was going to be negative 25 over 2. So that is what we're supposed to have simplified this part. You just have to be careful also on your calculator. So this, when you transposed it to the other side, it was going to be negative 25 over 8. Okay, so that's it. Then you divide. So this is the value of a, which was going to make or give us a remainder of 1 over 4 if we divide this expression by 4x minus 1. So if you are to use that long division concept, truly your remainder is going to be this. Okay, so if you've got time for that, guys, this is revision. You can also just try to prove and see if truly you are going to obtain a remainder of that, or you can just use the remainder concept. F of 1 over 4 must be equal to the remainder if you substitute that value of a. So if you are not obtaining the remainder of 1 over 4, it means it is wrong. Okay. On 1.3, simplify the following expressions. 1.31, we're given this, and that is 6 marks. Simplify this whole expression. Okay, let's see how we're supposed to attempt this typical question. So that was question 1.31, where we are given 2 over 6x squared plus 5xy minus 6y squared plus 1 over 3 y squared plus 5xy plus 2x squared. Okay, so if I'm to consider this here, like I said, to the factorization concept, that one is actually like in your hands, the way that you're gonna factorize. I don't know. You are going to apply that longer way of your factorization, 6x squared plus 5xy minus 6y squared, just like what we did last time. You multiply this to this term, you obtain negative 36x squared y squared. Then you find two terms that you multiply. When you multiply, they must give you this negative 36, but when added, remember they must give us a positive 5, and that was gonna be, think of the numbers 9 and a 4, because there's a possibility of a 5 there. But to obtain a positive 5, it means this 4 must be a negative. So the 4 must be a negative. Remember, we need 36, negative 36. So this 4 must be a negative. So meaning we can substitute these two terms. So that will be something like 6x squared plus 9xy minus 4xy. Remember, it's supposed to be x squared, y squared. So these two terms must also carry the xy that is there. Minus 6y squared. Okay, let's take them into two. What is common for the first two terms? It's going to be the highest common factor between 3 and, between 6 and 9 is going to be 3. And we also have x there, because here there's x. 6x squared to 3x, that was going to be 2x. So you're going to have 2x plus 3y. So factor out a negative 2 here, 2y, so that it can be positive. That was going to be positive 2x, positive 3y. Remember, when you factor out, you divide. So these two brackets are common. The bracket of 2x plus 3y is common, and the 3x minus 2y. So we have got 3x minus 2y there. So these are the two brackets that you could have obtained. So actually, guys, you do not need like to go through this. I'm just gonna talk about this on a separate class so that it does not affect our revisions, like I said before. Just gonna see in terms of our time so that we can help each other in finding shorter ways. You know, to know a shorter way, you must know the longer way first. So that if anything happens, you can recall back to the longer way that you are used to. So yeah, that's it. So you're gonna find time, guys, no problem. So let's just use our longer way here. 3y squared plus 5xy plus 2x squared again. Gonna multiply this and this, that will be 6. So we've got 6x squared, y squared. So this one, by just looking, guys, this is 6, this is 5. So the two terms there, we're going to be 3 and 2. So that will be 3xy plus 2xy, okay? Plus 2x squared. Into 2, what is common for the first two terms? 3x. So 3x squared and 3x, that will be x. 3x and 3x cancels, you remain with y there. 2x is common on the second bracket, so you're going to factor out 2x. That will be y here. Factor out 2x, that will be x. So as we can see, guys, x plus y and y plus x is the same. Remember, a plus b is equal to b plus a. It's just one and the same. Nothing has changed. Y is positive, x is positive. So meaning to say, it is still the same bracket. So you factor that bracket out, and what are you going to remain with? All right. So in this part that we are given, guys, this was 3y squared. 3y squared. So it was going to be a 3y here, guys, and it was going to be y plus x. I hope someone saw that. That was going to be y plus x. Okay, anyways, that had affected the bracket. No, the bracket is still the same. So the second one is still the same. Sorry for that. So guys, let's correct this part. This is 3y. So it was 3y squared. So it's going to be 3y here. Okay. So with this, like I said, y plus x and x plus y is just the same. Even with the second bracket also, let's say you wrote the first bracket as y plus x. I'm just saying, let's say this is how you've written your bracket as y plus x. And the other bracket, it was going to be 3y plus 2x like this. Guys, this presentation here is the same. You can even start with x plus y, 2x plus 3y. So this is just the same thing. So you can even start with a 2x, 3y. Why am I doing this? So that we maintain like the same way that we are given. If you check, we are starting with x. So if we also start with x in these brackets, it's going to be easier for you to work with later on. So these are the two brackets that you were going to obtain from your factorization concept. Like I said before, the way that you do factorize is in your hands. That one is your own, but you are going to have two brackets like this. That is what you're going to have. So how are we going to add now? From the addition concept, it's either we are going to find the LCD of these denominators, you maintain that one, or you make sure that you have the same denominators on these brackets that we are given. So you simply have to ask yourself, what is it that I do not have this side? That one is also in your hands. So the way that you're going to combine, like I said, it's in your hands again. So in this case, as for me, guys, I was going to choose the LCD at once. LCD or the LCM of these denominators. There is 2x plus 3y. There is 2x plus 3y. It's a repetition. So I'm just going to write it once. 2x plus 3y. All right. 3x minus 2y. I do not have it this side. So that's fine. Just going to also take it. Remember the LCD. You take every term. But if terms are repeating like this, just write it once. Also, we have got x plus y. Every part of the bracket in the denominator has to be taken. So the LCD divides to this denominator. So if you divide, you're going to see that the 2x plus 3y, the 3x minus 2y, we're going to cancel. You are going to remain with what? With x plus y. What you remain with is the one that you multiply to the numerator, x plus y. So in the same sense, if you divide this, you're going to see that the x plus y was going to divide with this. The 2x minus y was going to divide with this. You remain with what? With 3x minus 2y multiplied to a plus 1. So that's plus 1 into what was remaining when you divide, which is 3x minus 2y. Just like that. So this is your simplification now. Expanding of the brackets, collecting of like terms, 2 times x, or the first bracket, we can distribute this by the 2 outside, then the second bracket by 1. We've got numbers outside of the brackets. So 2 multiplies everything in the second bracket. In the first bracket, that's 2x plus 2y. 1 also multiplies everything in the second bracket. So that was going to be 3x minus 2y if you multiply everything by 1. The brackets as they are, we're just repeating. So here, we're just going to rewrite everything as it is. Okay, let's consider from there, what else can we do? Well, collecting of like terms, simplification. So we've got the 2x and the 3x. That was going to be 5x. We also have the 2y minus 2y. So that's a 0 there. So this actually cancels. So we are remaining with 5x. So it was going to be 5x over what we are given there, which is 2x plus 3y into 3x minus 2y into x plus 1, just like that. So meaning to say, we can have the simplification of fractions best under factorization. So you need to factorize whatever that you're given first, combined according to what you're given. Is it addition or subtraction? Addition and subtraction, you maintain the LCD throughout, which is your LCM throughout. You maintain that. Okay? Which is something else when it is on a division and you have to work with how the question is given. All right, 1.3 we are given. 1.32. Simplify again, but this time, what we are given, 6 marks again. Okay, let's see. That's 1.32. So 1.32, we are given to simplify. That was a bracket of 1 minus 2 over x squared plus 1. So do not be scared with these way, the presentations that you are given there. Work out the way that you do understand stage by stage. You see that actually there's nothing there. Okay. What is it that we are having? We've got a bracket, a bracket. Let's think of simplifying this bracket here into a single term, because that as it is, we've got a term here, another term here. So let's make it a single term. Combine again, meaning to say we are back to the addition and subtraction concept, but this time subtraction. So this is same as 1 over 1. So you can even consider that part of the LCD, which is going to be x squared plus 1. Okay, so what are you going to have if you divide this into 1? It was going to be x squared plus 1. Multiply to the numerator. So that's x squared plus 1. X squared plus 1 divided x squared plus 1, that's a 1. Then you're going to multiply to minus 2. Okay. There is a bracket also here. So this is same as x over 1 again. So meaning to say we have got our LCM of 1 and 1 minus x. So it is simply 1 minus x. Yes, guys, you can even write the 1 here. There's no effect, but guys, there's no effect. So let's divide. This divided by 1 is the 1 minus x. Then it multiplies to x. So it's x into 1 minus x minus 1 minus x and 1 minus x. That is a 1. But it's going to multiply to x plus 1. So take note. So you can even write this 1 here. It's just one and the same. But just make sure that the x plus 1 is in a bracket. So let's move on to the simplification. Remember what we need here. All right. Another part that we can sim. Okay, I'm going to talk about that one because already we ignored it in the first place. Okay. That will be x squared plus 1 minus 2 times 1. That's minus 2. Everything over x squared plus 1 multiplied to x and 1. That is x. X times minus x. That's minus x squared. Minus 1 multiplies x. That's minus x. Minus 1 and 1. That's minus 1. Everything over 1 minus x. So let's see what we are going to have at the end. The first bracket, there are like terms there, 1 minus 2, which is minus 1. So that's x squared minus 1 over x squared plus 1. Into the bracket, again here, we can simplify collecting of like terms, x minus x, that's a 0 there. So we are left with minus x squared minus 1, everything over 1 minus x. So actually, we could have avoided this in the first place. So like I said before, we could have avoided it here. Writing this starting with a positive so that we change this sign. So we could have avoided that long time. But anyways, even if you worked it this way, you are going to work it out at the end because you can see that in the first bracket, there is a difference of 2 squares, x squared minus 1. Remember your difference of 2 squares concept. A squared minus b squared is equal to a minus b into a plus b. So that's 1 is same as 1 squared. So we've got 2 brackets, x minus 1, x plus 1. Everything over x squared plus 1. Okay, so I'm just going to remove this bracket and use a normal multiplication sign. Okay, so this part here, if we were to consider properly, we can see there is a negative which is common. That can be factored out, and that was going to give us x squared plus 1. Negative, negative, positive, negative, negative, positive. In the same sense, again, there is a 1 minus x, this part here. Also, we can factor out the negative here so that this will be minus 1 minus x divided to this minus, it will be a plus x. But instead, minus 1 plus x is same as what? It is the same as x minus 1. So here we are just trying to rewrite the 1 minus x is the x minus 1. Remember, I talked about that if you're watching those videos on Algebraic. So we can actually change that. A minus b is the same as minus b a into minus b minus a. What is important is that once you introduce a negative, the b comes a positive, a negative. That is the order that you can remember with. So using that concept, you can actually see that we are now back to our normal simplification. Remember, negative, negative. As long as it is numerator to the denominator, x minus 1, x minus 1, x squared plus 1, x squared plus 1 can cancel. You remain with x plus 1 in the numerator, and that's x plus 1 over 1, which is same as x plus 1. So that's the whole idea. So you see, algebraic expressions, fractions, have got something in common, factorization, where it is possible. If there is no factorization, the normal simplification that you are used to must be maintained. The normal simplification. So for you not to waste much time in exam in algebra, revise as much of your algebraic expressions. You see that actually these marks here, it's actually supposed to be 19, like as you can see, but done within a short period of time. So we shall try as we move on, do more questions so that you can copy like some techniques that can be used to answer these typical questions. It will be best I explain that as a single or as a separate topic, not when answering the question paper like this. All right, question 2. Solve for x in each of the following equations. 2.11, we're given an equation and there was 4 marks. Okay. So let's see how we're supposed to have attempted this typical question. That's 2.1127 to the exponent of 3x minus 1 over 3 to the exponent of x minus 10 is equal to 0. These are exponents that we are working with, which is fine, but how can we solve? Let's figure out. There's something common here between the 27 and the 1 over 3. These can be written in the base of 3. Let's try to write them in the base of 3 and see what's going to happen. 27 is same as 3 to the exponent of 3 raised to the exponent of 3x. Okay? 1 over 3, remember, that's to the exponent of negative 1. But it is being raised to the exponent of x minus 10. And that's equal to 0. A 0, a normal 0. There's nothing there. So it's either you're going to write this as 3 to the x, but it's even impossible because that's a 0, not a 1. So there's nothing that you can do with the 0 there. So what they just tried to like what they were trying to do here, guys, is that remember, if A is equal to B, I can take this to the other side and write it as A minus B is equal to, I have removed this here. So what will remain if I remove it there? I have removed B. So nothing is remained. There's a 0 there. Not a 1. Not a 1, but a 0. So if A minus B is equal to 0, it means A is equal to B again. So what am I trying to say? If this minus this is equal to 0, we can move the 1 with the minus to the other side of the equation and see what is happening. 3 to the exponent of 3 to the exponent of 3x, okay? To the exponent of 3x is equal to, take it to the other side, that will be a positive. 3 to the exponent of negative 1 to the exponent of x minus 10. Guys, what is it that we understand about the exponents of the same bases and they are equal? What is on the left-hand side is equal to what is on the right-hand side. X to the exponent of A to be equal to x to the exponent of B. When these bases are the same, the exponents are equal also. We know that. So meaning to say, we need a single exponent, So that's 3 to the exponent of 3 times 3, which is 9x, is equal to 3 to the exponent of minus 1 times x, that's minus x, minus 1 times minus 10, that's a positive 10. we have got a single exponent that we can work with. These being equal gives us the power, say 9x is equal to minus x plus 10. So let's solve for x. This is now a linear equation. We are no longer having anything about exponents. It's now a linear equation, this one. So let's solve for x, guys. Transpose the minus x, this side is a positive. So meaning to say 9x plus x, that is 10x is equal to 10 divided by 10 by 10. So x is 1. Okay, so x was going to be equal to 1. You can also prove it by substituting the x value. You'll see that the right-hand side was going to be equal to a 0 if you do substitute that value. All right, for 4 marks, I think it was fair enough. I don't know, guys, how do you view it? 2.12, again, solve for x. The logarithm of x plus the logarithm of 5 minus the logarithm of 5x minus 1 is equal to the logarithm of a 4. And that was 5 marks. How can we solve this logarithmic equation? In our logarithms, based on the way that there is log throughout, we do not even have a number. Like if there was a certain number, we're going to think of something like log A base B is equal to C, where we can change this. A is equal to B to the exponent of C. Remember, there are laws like that. But we do not have anything to consider in this. But there are laws that can be considered if the bases are the same. Addition of logarithms, you multiply that part. Remember, from your formula sheet, you're given. Where are you taking the log AB? The log of AB taken from the addition of log A and the log of B. Where are we taking the log A over B? From the subtraction of log A and the log B. But in this case, if you're to consider that, you'll see that there is a part of x, there's a part of numbers only. What if we just take the x on its own, the numbers on its own, and see what's going to happen? Okay, let's take the x on its own. The logarithm of x minus the logarithm of 5x minus 1 is equal to, I'm going to have the logarithm of 4 this side, transpose this log 5. I'm going to take it to the other side of the equation there. So it's going to be a negative. So meaning to say there, we have got log 4 minus the log of 5. This, I have taken it to the right-hand side. So I want you to see something now here. These, not to say we could not combine them the way that we could have just combined. It's not a matter of fact, no. Because you're adding, you're going to multiply, then you divide. Okay, I'm going to talk about that. I'm going to do it so that we do not confuse each other. All right, but if you consider this way, at least if you see the x and the x, you can just, okay, here I'm dividing. Why? Because you're subtracting. The bases are the same, so you're going to divide the numbers. So that will be the log of x over 5x minus 1. It is equal to, again, we are subtracting here, so we're going to divide 4 over 5. Like this. Okay. So I want you to see this. There we have got a single log and a single log. It follows that there is no way that the log of A and the base of 10 be equal to the log of B and the base of 10. And these two are different. There is no way. These two must be equal, provided that the log, the base, the log, the base are the same. And this is exactly what we are given here. Log base 10, log base 10. So automatically this must be equal to this. So x over 5x minus 1 must be equal to 4 over 5. Guys, this is no longer a logarithmic equation. No. it's no longer a logarithmic equation at all. This is your normal equations where you can even cross multiply to remove the fractions. Then you can solve for x. 5 times x, 5x. 4 times 5x, that is 20x. 4 times minus 1, that's minus 4. So let's solve for x. You can transpose this to this side. That will be 5 minus 20, which is minus 15x is equal to minus 4 divided by negative 15. X was going to be 4 over 15. Just like that. So like I was saying that we could have, we could even have worked the way that it was originally without this part of, I'm going to take this to the other side of the equation. We could have just worked it out like that. What is happening here? There's a product. So a product, how are you going to simplify a product? You multiply x times 5. So that will be 5x. But after the product, after this addition, which gave us the product of the two terms, we are subtracting. So what are we going to do? Divide those terms. So we're going to divide to 5x minus 1. It was still going to give us the same thing. So we have simplified the left-hand side, everything there on the left-hand side. So this is equal to what is on the right-hand side, and on the right-hand side, there's a log 4. So we are still back to this part where the logarithms are the same. Of the same basis, we can take advantage and equate what we are seeing here. So it means the 5x over 5x minus 1 must be equal to 4. 4 is a whole number as a fraction that's over 1. So again, you can solve for x. In the same manner, just like that part, you're still going to have the same value of x in that solving part that you're going to have. So you must be careful. The simplification, guys, of mathematics is in your hands, like the way that you solve, you simplify. Don't limit yourself to a marking guideline, something, no. The marking guideline, that is why these days they are trying to even give us as many methods, ways, so that you see, guys, it's not a one way, so many ways. So prove with another way. If you're having the same thing, perfect that way, perfect it. That is what you understand, then perfect that way. Okay, 2.2, you are given, simplify the following. All right, 5 marks for this. Let me just try and increase it and make it here. That's x to the exponent of 1 over 2 plus x to the exponent of minus half to the exponent of 2. All right, they are actually trying by all means for you guys to understand, because you could have just expanded these brackets in the normal sense. I've got 2 brackets, I expand them, which is fine, which is very, very fine. But remember also, in our algebra, in terms of the factors, it's only that from our formula sheet, we are given the factors of a cubic. When you are given a cubic expression, the one of a cubed minus b cubed. Those are the ones that you are given, remember? But also, you must know for a quadratic, when you are given these brackets being raised to the exponent of 2, that a plus b to the exponent of 2 like this. All right, a plus b to the exponent of 2 like this. It is equal to a squared plus 2ab plus b squared. The first and the last squared is equal to the first squared plus 2 times the first and the last plus the last squared. If it is a minus b squared, it is going to be a squared minus 2ab plus b squared. You can memorize these. These are factors, just like identities in algebra. in algebra. Remember, you've got those ones for factorization. The ones that you are given in your formula sheet are the a cubed and b cubed. Those ones you are given, but these ones you are not. Just try to memorize. Or like I said, just expand 2 brackets, the ones that you are used to. You take 2 brackets, x to the exponent of 1 over 2 plus x to the exponent of minus 1 over 2, another bracket again. You expand 1 bracket into another. Guys, it's your choice. So if I was to use this concept, the first part, as you can see, there is same thing. A plus b to the power of 2. This was supposed to give us a squared, which is first squared, x to the exponent of 1 over 2 squared. So remember, exponent half times 2, that is 1. So it was going to be x to the exponent of 1, which is just x. Plus 2ab, that is 2 times a, x to the power of half times b, x to the exponent of minus half. So that was going to be 2x to the exponent of what? You're multiplying the bases, which are the same. You add the exponents. Half plus minus half, that's a 0. So 2x to the exponent of 0 is what? Is 2. Remember, any number to the power of 0 is 1. So 2 times 1 is just a 2. So that was going to be plus 2. Okay, then we move on to b squared. Last term squared, b squared. And our b, according to the first term, it's x to the exponent of minus half. But we have to square it. So just like the previous case, an exponent half, a minus half, and a 2, when multiplied, that was going to be a negative. So you're going to obtain -1. You're done with the first bracket. You have expanded the first bracket. Minus, so with this, you just have to expand direct to show this bracket times this bracket. I'm just saying, if you're using that bracket concept, is still fine. So let's move on to this one again. That's our a, but minus b this time. So we're going to work with this a minus b squared. So the first is supposed to be a squared. X to the power of half squared. This one, guys, is not going to change. It's still the same as what we had there. So that was going to be x. Okay, minus 2ab. So this one again is not going to change because these are the 2 terms, only that there is a minus this time. So it is going to be a -2. Plus b squared. This one also is not going to change. It's still the x to the power of minus half. So when you square it, it's going to be x to the power of -1. So working out the first bracket was enough. What you just do is that the second bracket is the same. The only difference is that there is a plus, here there is a minus. So in this case, this is going to be a minus. Only this part is going to be a minus. So that's it. Guys, like I said, there were so many ways. I'm going to show another way again. Let's finish up this one. So in this case, we can see that at the end, we can expand the brackets. The second bracket, that will be -1 by minus. So minus times x, that's minus x, minus times -2, plus 2, minus times minus, that's minus x to the exponent of -1. Expand the brackets by that negative that you are given. So let's collect like terms x minus x, that's a 0. 2 plus 2, that was going to be a 4. The x to the exponent of -1 over 1, x to the exponent of -1, I mean, and the x to the exponent of -1, we're going to cancel. So that was going to be a 4. Guys, like I'm saying, this here, what does it mean? This here, if you see this in the first place, besides that they are brackets, by just looking into the squared minus this, what is it that you are seeing? A difference of 2 squares. So we could have simplified this using the difference of 2 squares concept. A squared minus b squared is equal to what? A minus b into a plus b. This is what we know. So this is the whole of this. You are taking the bracket as your a, the whole of the bracket, this one, as your a. the whole of this bracket as your B. This is the bracket that is being squared. So this is your A, this is your B, using the difference of two squares. So meaning to say, from the difference of two squares concept, you must have two brackets, A minus B. So our A is the first bracket as it is, x to the exponent of 1 over 2 plus x to the exponent of minus 1 over 2. This is our A. Minus B, our B, we take our B, this is our B, x to the exponent of 1 over 2 minus x to the exponent of minus 1 over 2, like this. Into the bracket again of A plus B. Our A as it is x to the exponent of 1 over 2 plus x to the exponent of 1. This is our A, plus B, the B as it is. So a plus does not affect. So just going to take as it is, x to the exponent of 1 over 2 minus x to the exponent of minus 1 over 2, like this. So this is A minus B into A plus B. Okay, the first bracket, as we can see, we're going to expand by a negative here. So it was going to be minus, minus, here it was going to be a plus. Okay, so you can collect the like terms. X to the power of minus half minus this, it was going to cancel. X to the power of minus half plus x to the power of minus half. This is 1, this is 1. These are like terms. 1 plus 1, that's a 2. So it was going to be 2x to the exponent of minus half. So this is what you're going to have from the first bracket. The second bracket, do the same thing, collect like terms. So this is 1 x to the power of half, 1 x to the power of half. So you can add 1 plus 1. That was going to be a 2. X to the power of a half. This one and this one was going to cancel. They are just the same. Okay? This is where you are. This is where you are now. This is another way. So many ways. So at this stage, what am I going to do? Expand the bracket. 4, in this case, 2 times 2. That was going to be a 4. X and x, you're multiplying the bases which are the same. What is that you do? Remember, if you're multiplying the bases which are the same, you add the exponents. So it's minus half plus a half, which is x to the exponent of a 0. And what is x to the exponent of a 0? That is a 1. So 1 times 4, that still gives us the 4. So many ways that you can simplify. So like I said, you could have even expanded the brackets. You take one bracket, another bracket, you expand. Minus, you do the same thing from this one. So I want you to try that one. Take this in this bracket, you expand the same, because the squared means times 2, this times 2. There's this times itself, like that bracket times that bracket again. You expand the same way that you are used to with your algebraic expressions. That's how you can work it out. All right, on number 3, we are given, that's a word problem there. If you are to consider, we are given 3.1. The sum of 6 times a number and 5 times another number. The moment you're given this number, another number, think of simultaneous equations, because a number is an unknown. Another number, again, it's an unknown. So the first number, we do not know. So you can just let our first number be x and also our second number be y. Okay, so they're saying the sum addition, you add 6 times a number. So it's 6 times a number, which is our first number, plus, because they said it's a sum, 5 times another number. So 5 times another, which is the second one, which is 5y. So this sum must be equal to 648. It's an equation that you have formed. However, the difference between 2 times the first number and 5 times the second, take note, the difference between 2 times the first, our first number is x. So 2 times, that's 2 times x. But they are saying the difference minus 5 times the second number. So that's 5y. That difference is of 600. It's an equation again that we have formed. So determine the numbers. Solve for x and y because these are the numbers that we do not know. So it's an equation. So the problem is that when we have these equations, we only think of the substitution and you want to force substitution always. Let this, no. Yes, you can use your substitution method, which is fine. Substitution method, you can make x the subject, substitute in another equation. Or what you can do is that, as we can see in this case, there is something that is common. There is a 5y, a 5y. So we can eliminate that y. So we can try to eliminate y. But how can we eliminate y? To eliminate is to remove that y. So the question is, how are we going to remove this part? Are we going to add the 2 or are we going to subtract? If we subtract, I want you to see, it was going to be 5y minus 5y. You haven't eliminated because it will be a plus. So 5 plus 5 is now a 10. So a plus was not going to work. I mean, a minus was not going to work, but a plus. If you add 5y plus minus 5y, that's minus. So 5 minus 5, that's a 0 because we are now having minus there. Remember, a plus and a minus gives you a minus. So meaning to say, in this equation, in order for us to eliminate these two, we were going to add equation 1 and equation 2. So if you add equation 1 and equation 2, you are going to remove the part of y. So let's add 6 plus 2. That's 8x. Remember, here we added, it's no longer there, that's a 0. 648 plus 600, you add. That side, it was going to be 1,248. Divide by 8 both sides. That's obtaining the value of x, which is 156. In the same sense of our substitution, knowing that I have got the x value, I can substitute in any equation to find the y value. We are used to that one. So I can pick any equation of my choice, equation 1, equation 2, that one, it is your choice. So in this case, as for me, I was going to substitute from equation 1. So from equation 1, I'm going to substitute this x value, 6x, that is in place of x, I'm going to substitute 156 plus 5y is equal to 648. Then I can solve for y. So let's solve for y in this case. So 5y is equal to, if you multiply these two, take it to the other side, you subtract the difference there of 6 and 156, whatever value that you're going to obtain there, you divide to 5 actually, guys. Just divide by 5 by 5. Whatever answer that you're going to get here, you divide it by 5. That was going to give us the value of y. So it was going to be minus 288. If you subtract, then you divide by 5, it was going to be minus 5, minus 57,6. So use your calculator properly also. So these are the numbers, the two numbers that when you apply the concept that you are given them, they are going to maintain that statement. Okay. Make R the subject of the formula. In this equation that we are seeing, we need to make R the subject. 3 marks for that. 3.2. Okay, so let's see. So on 3.2, we are given something of this nature. That is V is equal to A minus 2Q over K, and we are given the logarithm of R in the base of E. They now know that, guys, these logarithm you are used to them actually. Let me just be fast about this. We can consider the ln, but already the log, they have given you the log. So guys, just get rid of the negative, the term that you're working with to be a negative. We can avoid that. We can take it to the other side of the equation so that it can be a positive. So I can have 2Q over K, the logarithm of R in base of E. This is a single term, this one. It's a single term. It's under multiplication. It's a single term. So the moment you take it this side, you are taking as it is, but the sign is going to change. So this is equal to, already there is A on the right-hand side, minus, we take the V, this side is going to be minus. So that's minus V. Remember, you want to make R the subject. So what is it that is affecting this time? There is this 2Q over K. Instead of dividing by it, is going to make a senseless fraction here. So how can we make this fraction to be at least much better in terms of the presentation? You remove this way, is 2Q over K. So you multiply by the reciprocal of what you're given. Take K on top, 2Q in the denominator. That reciprocal, you're going to use it also this side. That is how you can get rid of this. So this and this can easily cancel. So you are left with the logarithm of R in the base of E, which is equal to this bracket times K. So it is simply something like this, K over 2Q into the bracket of A minus V, or even the way that is like this, there's no problem. So back to our logarithms. Remember, we do understand that the log of A in the base of B, for it to be equal to C, this A must be equal to B to the exponent of C. So the R that we want, this one, can be determined as the base, which is our B to the exponent of the answer. So it's E to the exponent of everything on the right-hand side. So meaning to say, from this, we can conclude that therefore our R is equal to the base to the exponent of this. That is E to the exponent of K over 2Q into A minus V. R is the subject of the formula, just like that. So the change of subject is not that much. It's not that much. It's just like you're solving an equation, a normal equation, just like the way that you're solving your normal equations. All right. 3.3, if x is equal to, actually not x, but if minus 3 over 2 is a solution, like you're solving this, then you obtain x is equal to minus 3 over 2. So they are saying, if this is a solution to the quadratic equation that you're given, find k and the other solution. Okay, 5 marks. They want to bring an idiom of the factor and remainder theorem again. If you do understand that way, it was going to be the easiest way to answer this question. Because they are saying minus 3 over 2 is a solution that is the root of a certain equation. Like you solved x is equal to minus, you have solved that. Remember, guys, on that question that we did of factor and remainder theorem, I said you are going to let that expression that you are given, it was 4x minus 1, if you still remember. And we solved that, let it be equal to 0. Then we solved and got x is equal to 1 over 4. There, they already solved. They are saying this is minus 3 over 2. They already solved that. They already solved a certain solution of an equation which was given as kx squared plus plus x minus 3 is equal to 0. This here, what does it represent? It is the same as your f of x from your normal functions. It is the same as your f of x. So using the factor theorem, there is no way a solution is taken from a factor. It was taken from a factor. For us to have this solution, it was taken from a factor. So if it was taken from a factor, it means f of x, which is the x value that you are given here of minus 3 over 2, it is equal to 0. There is no remainder. There is no remainder. We're using the factor and remainder theorem concept. There's no remainder there. It's a factor, a solution. We are having a direct factor. So what does that part mean, actually? Remember, I talked about this. In place of x, substitute this to obtain a 0. So wherever there is x, you're going to substitute the x value that you're given, which is the minus 3 over 2, into x. So meaning to say minus 3 over 2 squared times k plus x minus 3 over 2 minus 3 must be equal to 0 because it is a factor. You formed an equation that you can solve for k. Minus 3 over 2 squared, that was going to be something like 9 over 4. So you've got 9 over 4k. Okay, then you can even combine these guys just like previously. Just combine these. Those are just normal numbers on your calculator. Minus 9 over 2 is equal to 0. So you can even solve for k, transpose this to the other side, it becomes a positive. So that means 9 over 4k is equal to 9 over 2. So to find the k, divide by what is multiplying, 9 over 4. Or you can do those cross multiplication, guys. It's in your hands. Just divide by 9 over 4. This can cancel. So those two terms, divide them on the other side. Okay, that was k was going to give you a 2. Just like that. So it was like taken from the factor and remainder theorem concept. If you understand it that way, you can use it. But the question is not ending there. They also want you to determine the other solution. Remember, this was the first solution. We also need the other solution. What is going to be the other solution? Knowing that our k is 2. K is the part of our equation that we had before here. So to determine the other solution, you can just substitute. You can just substitute the k that you're given, then solve. Because you have k and now as 2. So our equation is going to be 2x squared plus x minus 3 is equal to 0. Then solve. It's a quadratic equation that you're given. So you can use the quadratic formula, whatever that you want. But on doing that, you're going to see one of the solutions is going to be minus 3 over 2. So if you use your quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. You can substitute the values. Remember, that's your a, the coefficient of x, which is your b, and c, which is a constant. So in this case, x was going to be equal to minus b, which is minus 1, plus or minus the square root of b squared, that's 1 squared, minus 4 times a, which is 2, times c, which is minus 3, everything over 2 times a, which is 2 times 2. So with this, we can solve for x, and you're going to obtain two possible values, x, which is 1, and another x, which was going to be minus 3 over 2. But already, we need the other root. This one is the one that we were given before. They gave us this. So meaning to say, therefore, the other root was x is equal to what? X is equal to 1. Remember, previously, they gave us minus 3 over 2. So if you solve, and you do not obtain minus 3 over 2, it means that k is wrong. Or maybe the substitution thereafter that you made when solving your equation is wrong. There's no way that it was a solution of that and you substituted the k that you got there, which you are saying it is the one maintaining that statement. And when you solve now, it gives you something which is not part of the statement. It means it is just wrong. You have to consider your k value or the substitution thereafter to see where you have made a mistake. So that was 12 marks on everything on question number 3. So you have to figure out these typical questions that you are given. So there we just, let's see. You have to figure out like, what is it that I'm given? Study your questions as well. That is very, very important. If you are to consider our question number 4, this was the coordinate geometry, which is the part of our geometry. Let's see how you're supposed to have attempted this one. So with their saying, consider this fig A. We have got the point A. The point B, C are the vertices of a triangle. Okay. Yes, they're forming a triangle. And the point Q is given. P and Q are midpoints of A, B, B, C respectively. So take note. P is the midpoint of what? Of A, B, this one. So we have got a midpoint here. Remember, we are told that's the midpoint, and also Q is the midpoint. Q is the midpoint of what? Of AC, the line AC. Okay, then theta is the angle of inclination between the x-axis and the line AB. Okay, as we can see, that's our theta there. So that was our diagram that we are going to work with. You can also convert these to fractions, decimals, whatever part that you understand. Okay, it's not a problem. Let's see our questions. So from this diagram, the questions now are 4.1, determine 4.11, the coordinates of A, 4 marks. A is the point, which is the vertex at this point at the top of our triangle there. And we are told P is the midpoint, Q is also the midpoint. So it was up to you. Either use P or use Q as the midpoints. Use the midpoint concept. What is it about the midpoint? So do not worry about part of your geometry, part of the straight line. We are given, in this case, what we need. The midpoint, P is given, x1 plus x2 over 2, y1 plus y2 over 2. So remember your midpoint concept. So using that midpoint concept, we can attempt our question. So that's 4.11. So you're going to choose which midpoint? B, from the line AB, P is the midpoint. So the midpoint, we saw that it is given by x1, x2, x1 plus x2 over 2, y1 plus y2 over 2. So if you understand this, already you've got your formula. So there's no need for you to worry about much because A is the one that is given as xy. So you're simply going to add the x values, the x value here and the x value at B. So in this case, I'm going to choose the line AB. So from the midpoint of the line AB, x on A plus the x on B, which is 1 over 2. That's the mid value. The y at A, which is y, and the y at B, which is minus 3. Together divided by 2, that's the mid value for the y, which must be equal exactly to the midpoint that I'm given there, which is 4, 1, which is our point P. We are already given the midpoint. We are already given the midpoint, guys. We are using this line. So I want you to prove using the side of AC using Q as your midpoint. So in this case, there's no way. The X here has to be equal to the X. Remember, it's a point representing XY, representing XY. So the part of X is equal to the part of X. So that's it. X plus 1 over 2 is equal to 4. Therefore, you can solve for X. Cross multiply. So that is 1 times X plus 1. That's X plus 1. 2 times 4 is equal to 8. So from this, we can transpose 1 to the other side. That will be a minus this side. So X is equal to 7. 8 minus 1. Using the same concept, you can solve for this because this also for Y is equal to the Y value, meaning to say Y plus and minus, that's a minus 3 over 2 must be equal to 1, and 1 is same as 1 over 1. So you can also cross multiply. Y minus 3 is equal to 2. So Y is equal to what? Minus 3 to the other side, that will be a plus. 2 plus 3, which is 5. I have the X and the Y value at point A, So therefore, our point A, X being 7, Y being 5. So we've got the point A. Meaning we can also write it down for the later use. So that's 7, 5. So we've got our point A. So midpoint concept was going to be the best to use. So like I said, I want you to try working with the other side using the line A, AC. Okay, I want you to try that one. Let's see the other part of our question. We now have the point A. The other part, it was the length of the line segment AC and simplest said form, the length of a line. How do you determine the length of a line? That is the distance between the points, D being the distance. So you can use the distance formula, x2 minus x1 squared over plus y2 minus y1 over the 1. Given the square root that you're given, everything under the square root. So that's 4.12. So we need the distance of the line AC. We have the point A, the point C. So from that, we saw that it's going to be x2 minus x1 squared, y2 minus y1 squared. So this is in your hands. You can just name whatever that you want, x1, y1, x2, y2. So that's x2 minus x1. So it means AC is going to be the square root of x2, which is 8 minus 7. So that's 8 minus 7 squared. Y2 minus y1, that's minus 2 on y minus 5. Just like that. So you can even take any way. You can even use the other way. Still one and the same thing. So that was going to give us AC. Use your calculator in said form. That was 5 square root of 2. Remember the length measured in units. So this is the simplest said. The question is not just in said form, but in simplest said form. 4.13, the gradient of the line AB, the gradient, remember, from the change in Y over the change in X. Also, we are given this from our formula sheet. All right, that is not given. Now, guys, we're supposed to be given this. You're supposed to be given this. But anyways, that is also part that you also need in terms of the gradient. So the gradient, which is M, is equal to the change in Y over the change in X. So we are going to use this, or you can use Y1 minus Y2 over X1 minus X2. It's in your hands again. So this is the formula that you can use. So you need the gradient of line AB. So this is our AB. Okay. This is our AB. A and B. So remember our A and our B. So A is already there. So that's 4.13. So from that formula, the gradient of the line AB from the change in Y over the change in X is going to be Y2 minus Y1 over X2 minus X1. So again, it's in your hands. You can just name this X1, Y1, then this will be X2, Y2. So Y2, that is minus 3. Remember the point B there is 1 minus 3. 1 minus 3. So that is minus 3 minus 5. Okay, the X value here, that is 1 minus the X value, which is 7. So that is it. On your calculator, simplify, that was going to be minus 8 over minus 6, which is 4 over 3. So this is the gradient of AB. Okay, direct like that, we can calculate the size of theta, the angle of inclination. All right. So remember that the angle of inclination also can be calculated theta, which is arctan m. M is the gradient that you calculated before. So meaning to say, we can calculate our theta, which is between the line AB and the x-axis. So that was the idea then. We have already calculated the gradient of AB, and theta is in between the line AB and the x-axis. So that was a straightforward calculation that you're going to have. So our theta is equal to the arctan of the gradient of AB. So we calculated the gradient of AB, so it's just a substitution. Theta was going to be arctan of this gradient, which is 4 over 3. And this is an acute angle. No adjustments according to the theta that we are given. It is on the right side of our line. So there's no adjustment. There's nothing that you're subtracting. The angle that you're obtaining from your calculator, it is the one. So that is what you're supposed to have attempted. This one, it was just from your gradient, the one that you calculated before. Then another question, it is the equation of the line passing through the point C, which is parallel to AB. So it passes through point C parallel to AB. So there are two things here. We need the equation, but there is something about parallel lines. What is it? Their gradients must be equal. The gradient of the first line is equal to the gradient of the second line. That is for parallel lines. If you want to use this equation to find your equation, it's fine, or you can just use y is equal to mx plus c direct again. So we are told it must pass through the point C parallel to AB. Okay, so these are two things that we need here. It must pass through the point C. So already the point C is given. The point C, we have it. So we already have the point there, which is the point C. It's already given 8 minus 2. But this line is supposed to be parallel to AB. So being parallel to AB, it means our gradient must be equal to the gradient of the line AB. We are told that two lines are parallel, they've got same gradient. So already AB, its gradient is there, 4 over 3. We calculated this. So meaning to say the gradient was going to be 4 over 3. Having a point and a gradient, it is enough for us to determine the equation of the line in the form of y is equal to mx plus c as we are given. We can just substitute m being the gradient, that is 4 over 3x plus c. So you determine c from the point that you're given. You can substitute what is y in place of y and what is x in place of x. So y is minus 2. Minus 2 is equal to 4 over 3 times x, which is 8, plus c. Combine, then transpose to the left-hand side, you can determine the value of c. So that was going to be minus 2 is equal to 32 over 3 plus c. Then transpose this, it becomes a negative on that side. So it was going to be negative 38 over 3 equal to c. So having the c, we can substitute back into our equation. So therefore, y is equal to 4 over 3x plus c, which is plus this. So that will be a minus 38 over 3. This is, oh, it was a little bit straightforward. The point and the gradient, these two are enough for you to have the equation of a line. So that was it. Then prove that BC, that was 4.2. Prove that these two, they are perpendicular. BC is perpendicular to AC, 4 marks. BC and AC. All right. So how can we prove that the line BC, where is BC, this one, and AC, they are saying these two lines, they are perpendicular. There must be a 90 degrees there. Okay, this one, I think we can just take it straight, guys, from the concept of the gradients again, because there is everything. The points are there. The points are already there. So let's go back to the perpendicular concept. The product of the gradients this time must be -1. If two lines are perpendicular, the product of their gradients must be a -1. So in this case, we are working with the line BC. Remember, this is what we need. So that's 4.2. So we want to prove that BC is perpendicular to AC. This is what you're supposed to prove. The gradient of BC, are we having it? The gradient of BC, no, we never calculated that. The gradient of AC, are we having it? No, we never calculated that. So we need the gradients only. That is to prove. That's why you see 4 marks. So you just need to calculate your gradients in this case. So what is the gradient of BC? The gradient of BC, remember the change in y over the change in x. We have got the point B and C in this case. So the y values, that is y2 minus y1 over x2 minus x1. We can substitute y2 on C, which is -2 minus y1 on B, which is -3 over x2, which is on C, that is 8 minus x1, which is a 1 on point B. So that was going to give us 1/7. That's the gradient of BC. Using the same concept of the gradient, we can calculate the gradient of AC. So in this case, the gradient of AC from the change in y, that is y2, is -2 minus y1, which is 5, over x2, that is 8, minus x1, which is 7. This was going to give us a gradient of -7. That is the gradient of AC. But we saw that from the formula, the products must be -1. So let's see. The product of this BC, the gradient, to that of AC. Let's multiply and see what we are going to have at the end. So if we are to multiply this BC, that is 1/7, times AC -7, you're going to obtain -1. There is no way that you are multiplying two gradients of different lines, obtain -1, and those lines are not perpendicular. There's no way. This is a condition that we know that can only be achieved by lines which are perpendicular. So by this, it is a simple indication that these two lines, they are perpendicular. So therefore, these two lines, they are perpendicular, BC and AC. So therefore, BC is perpendicular to AC, since the product of the gradients is -1. So that is how we are supposed to have attempted this typical question. You just have to work from the gradients. If you want to prove that two lines are parallel, again, you can use the same concept, but for parallel lines, they must have the same gradient. Like I said before, must have the same gradient. Okay. Let us see what we are given on question number 5. So as we are given from our instruction, remember we're told not to use the graph paper. We are going to draw this in the answer book. All right. 5.1, draw the graph of the following in the answer book, showing all the intercepts with the axis. So there we are given 9x squared plus 4y squared is equal to 36. So that is an ellipse that you are working with there. All right. So remember, there you are having two different terms. I mean, the numbers that we are given, they are different. They are not the same. This is 9x squared, 4y squared. These two numbers are not the same. This number and this one are not the same. The 9 and the 4. If they are the same, it was going to be a circle. Okay, so if they were the same, it was going to affect that to be a circle, like I said before, but being different, it makes to be an ellipse. So meaning to say, in this case, you are simply working with an ellipse. All right. So with the concept, we need the intercepts. So the intercepts are not going to change whether you are working with a circle or you are working with an ellipse. The concept is not going to change for the x-intercept. Remember your conditions. Y must be equal to 0. So if y is equal to 0, it means we do not have this part. We just have 9x squared equal to 36. So let's solve for x. So we can solve for x from there. If x squared is 4, then simply the square root x was going to be plus or minus 2. The same thing, if you are to consider the y-intercept, it's on a condition where x is 0. So if this is a 0, then that means we are going to have 4y squared equal to 36. So that's it. We're going to also solve for y. So y squared being 9, meaning to say y is going to be plus or minus 3. So these are the intercepts that they need you to just show on the graph. I mean, on your answer book. You're going to indicate, like in the x-axis and in the y-axis, these points. So that is, you've got the x and the y. So by just looking, you can see that the x is at plus 2 and minus 2. So let's say I've got 0, 1, 2, 3, something like this. So just gonna have 1, 2, 3, 4, and so on. Minus 1, minus 2, minus 3. So what is important is the x at positive 2 and at negative 2. The y value, positive, negative 3. Positive 3 and negative 3. Then from there, you're going to join. And what is it that you're obtaining? That is an ellipse. So you must also just draw something that is neat, but that is a sketch of what you're going to have at the end. So that is an ellipse. A circle, it must be, all the values must be the same. You must have, if it is 2, same values. So it must be directed from these two values that you're given. But even if you do not understand the concept there, by calculating your x-intercepts and your y-intercepts, seeing that they are different tells you that it's not a circle. Because for a circle, the values are supposed to be the same. All right, so considering 5.2, determine dy dx, the derivative of y with respect to x of this function. By making use of the rules of differentiation, the final answer must be with positive exponents and in said form where applicable. Okay, so this is what you were given, and you are supposed to find the derivative of each part that you are given using the basics or the basic rules of our derivatives. All right, what are the basic rules that we have? We are given y is equal to 2 over x squared plus the square root of x. And the other part, it was 1 over x times pi, like this. Okay. From our basics of our derivatives, this is what we have. That is the derivative of x to the exponent of n. Whenever you're given this, you drop the exponent, which is your n, to multiply whatever that you have, then you subtract 1. So what you're given here is the format of whatever that you must find its derivative. It must be of x raised to a certain power, x raised to a certain exponent. So in this case, is it what we are having here? No, this is a fraction. It's in the denominator. So let us bring this on top. How can we write this on top? Back to your laws of exponents. That will be to a negative exponent. The square root of x, it is the same as to the exponent of a half. Again, there we've got 1 over x. So in this case, it is same as x to the exponent of -1, just like what we have on 2 over x squared. So we can find the derivative if it is like this. Remember, the concept is that you're supposed to drop this to multiply whatever that you have, then you subtract 1 on the exponent. So if we are to drop this to multiply, that means you are now finding the derivative of y with respect to x. So you're going to multiply -2 and the 2, that is -4. You subtract 1 on the exponent. So that is x to the exponent of -3. You do the same thing on this part. You drop the exponent, there's a 1 there, subtract 1. So meaning to say a half multiplies a 1, that is going to be a half. That's a positive. 1 over 2x to the exponent of -1/2. With the same concept, in this case, we are going to multiply by -1, you subtract 1. -1 times pi, that is minus pi, x to the exponent of -2. -1, -1. So in each and every concept there of your basic derivative, you drop the exponent, subtract 1, but they told us that we are supposed to maintain this part of our positive exponents and also to be in said form where applicable. So just like what we had before, it was a positive here, then we wrote it on top with a negative. Now we have that negative, so you're supposed to bring this to the denominator to remove these negatives that we are seeing here. They must be written in the denominator. So meaning to say that will be -4 over x to the exponent of a +3 plus 1 over 2. So this is 1 over 2x to the exponent of 1 over 2 minus pi over x to the exponent of a 2. They are positive exponents now, but the square root there, remember, to the exponent of a half, we took this from a square root. So it can also be rewritten as in said form, that is with a square root. So that's therefore the derivative of y with respect to x was going to be -4 over x to the exponent of 3 plus 1 over 2. This is the one that we are working with. X to the exponent of a half, that is the square root of x. This is the said form. Minus pi over x squared, which we can just leave it like that. So meaning to say, the simplification there, it was just our basic rules of our derivatives, then also the laws of exponents to be applied. 5.3, given this function, f of x. So we have got a function to consider, f of x, which is equal to -2x to the exponent of 3 minus x squared. With this function, we are given 5.31. If 0, 0 is one of the turning points of f of x, make use of differentiation to determine the coordinates of the other turning point. So whether we are given that it's one of the turning point, it actually does not make sense. because the finding there of the turning point is not affected because you are given another turning point. Does not affect. So what is the concept now about the turning point? You're also given the situation of the turning point from your formula sheet. Maximum and minimum values. For turning points, the first derivative must be equal to 0. For your turning points, the first derivative must be equal to 0. So meaning to say we are simply working with that concept of the first derivative to be equal to a 0. So what is the first derivative of our expression? Remember to differentiate. This is what we're just doing. Multiply these two, subtract 1 on the exponent. 3 times minus 2, minus 6, we subtract 1, that's x squared. Minus, you multiply by 2, that will be minus 2x. So this is our first derivative, but it must be equal to 0. So meaning to say minus 6x squared minus 2x must be equal to 0 at the turning point. So that is, we can solve for x. It's now an equation that you have formed. You can solve for x. You have an equation now. So how are you going to solve for x? You can factor out. Never be tempted to divide. It's an equation. By dividing, you're taking out some of the factors there. So you factor out instead of dividing. You factor out. So you can factor out minus 2x, which is common, or you can just, even if you do not want to have confusion, just factor out x. And this will be minus 6x, and that will be minus 2 is equal to 0. Remember the 0 concept. The product of 2 to be equal to 0, one must be equal to 0, or the other one must be equal to 0 also. So it means one of these two terms must be equal to 0. This x or the bracket of minus 6x minus 2 must be equal to 0. That's where we have our solutions now. X must be equal to 0, or the minus 6x minus 2 is equal to 0. So at x is equal to 0, it is this one that we are already given here. The first one where they told us, this one. X is equal to 0. If you were to substitute it here, we're going to say that y was equal to 0. So this one is already given. So as we are focusing on this side, so let's solve this side. Minus 6x is equal to transpose 2 to the other side. That will be a positive 2. Divide by negative 6. So x is going to be 2 over minus 6, which is actually minus a third. So we've got the x value there. So this is the other part of our turning point. But it's a point, remember? So how do you write this? So the other turning point, the x is the one that you are given, minus a third. What about the y value? Because the point is made up of x and y. So you substitute back into the original function in place of f of x. F of minus a third. You substitute wherever there is x, you substitute minus a third. So meaning to say, y was simply going to be, in place of x, that will be minus 2 into minus a third to the exponent of 3 minus a third to the exponent of 2. So that was going to give us minus 1 over 27, which is the y value at the turning point, minus 1 over 27. So that's the other turning point. From the 0 that we are given, that's the first turning point that you're already given. So it's nothing to work out from there. All right, then we are given on 5.32 that A0 and 0, are the points of intersection of F with the x-axis. Determine A. The intersection of F with the x-axis, meaning to say we are talking about the solutions. These are the values of x where the graph meets the x-axis. These are the x-intercepts, the solutions of the function. So here the A is simply the other solution. So they gave you one solution, find A's another solution. So you see how they try to manipulate what you are used to in terms of answering this question. You are used to when they ask you a simple question, determine the x-intercepts or solve f of x is equal to 0. So instead of being given that way, they are telling you this is at an intersection of f with the x-axis. A function and the x-axis where they meet, these are the solutions that you are referring to. So the solutions are at a condition where y is equal to 0. So that's 5.32. Remember the solutions in the x-axis, y is equal to 0. So if y is equal to 0, this whole function is equal to 0. Minus 2x cubed minus x squared is equal to 0. So we can solve for x like this. So x squared is common. We can factor out x squared. You remain with minus 2x here. Okay, minus 1 is equal to 0. Remember the 0 concept. X squared must be equal to 0, or this bracket must be also equal to 0. So if x squared is 0, it means x is also simply a 0 from there, because the square root of a 0 is a 0. So x is a 0. But remember, there were supposed to be two solutions here. X is equal to 0 or x is equal to 0 again. So you must consider that when this happens, it simply shows you that that solution, it's also a turning point. It's a solution, it's the root of the function, but it's also a turning point where x is 0. I'm going to talk about that. All right, so here let's solve for x from this other solution that we are given. Minus 2x is equal to a positive 1. Divide by minus 2 by minus 2. So x was going to be minus 1 over 2. So this is the x value. Remember, this is on a condition where y is equal to 0. So x is what? Minus half. So this is the one that we are given here. A0, 0, 0. So the a is the x value that we just calculated now, which is this minus half. So therefore, a is equal to minus half. It was simply the x value at as a solution at the x-intercept where y is equal to 0. So with this, you are now asked to sketch this f of x, showing all the points of the intercepts of the x's and the turning points. All right, remember your f of x. What is important are the turning points, the shape. So I'm just gonna try have our sketch here. Let's hope it's gonna be fine. That's 5.33. So if you are to consider this one, it is a function that is important to consider that much, because like I said, on the solutions here, one of the solutions is also a turning point. At 0, there is a solution and it's also a turning point. This function, it carries a negative. The coefficient of x cubed, it's a negative. So meaning to say, we're actually expecting something like this, but it's no longer going to have a condition where there are 3 solutions, because one of the solution is a turning point. One of these solutions is a turning point. So we are going to only have 2 solutions. That's where we are seeing the 0 and the minus half. So minus half, remember, it is the x value. So according to the shape, remember, this is a solution, this one. So your function was going to pass like this. It passes through the solution, goes to the turning point. But as it goes to this turning point, it must have another solution here. But it is not going to pass that solution, because that solution, it is also a turning point. So as you are to reach this solution, you must indicate a turning point there. It is no longer a normal solution, it is also a turning point at the same time. So that is what you're going to have at the point 0 there. It is a solution and also a turning point. But this one, it is on its own. Remember, our turning points, there were two. The one at 0, 0, this one, and this one that we calculated at minus third minus 1 over 27. That's minus a third minus 1 over 27. It's also a turning point. So there are 2 points, turning points. But this one, it's a turning point and a solution. So the graph does not pass like this, no. It turns at that point 0 like this, okay? So that was just the sketch there. Remember, just a sketch that you are given. So that is our f, which is our f of x. So with this, you're going to obtain full marks. You show the solution here, everything, okay? Everything you've showed on your graph. So that was our question 5.3. 18 marks on everything on question number 5, which is important that you do understand these typical questions. Like I said, that they can also have a repetition of these similar questions that you have there. All right, let's consider another part of our question, which was question 6. 6.1, use the trigonometric identities to prove that these two are equal. Using your trigonometric identities, and this is what you have on your trigonometry. So we want to say, I'm just going to work it here so that we can just relate quickly on what we are given. So we were given the tan, that was 1 plus the tan of b, everything over 1 plus the cot of b being equal to the tan of b. Is it b or beta? That was a beta there. Okay. So in this case, remember you have to prove. So you can take the left-hand side, which is the complicated side. There's a lot of things to consider them. So from the left-hand side, we are given 1 plus tan beta, everything over 1 plus cot beta. Okay, let me just have a closer look. This is just B, guys. This is just a B that we are seeing. It's not like a beta or a what. This is just B, this one. Okay, sorry for that. So this one, it is just B, the normal B that we are used to. This one is just B. So how can we prove that? Is there anything that we can get rid? Yes, the tan, the cot. They have got equivalent ratios there. The tan, remember, is sine over cos. So if I was to write this in terms of a sine and a cos, it was going to be 1 plus sine b over cos b, which is in place of the tan b. So it is going to be sine b over cos b. Everything over this, which means if we say everything over, it simply means a division like this. So you can even have it as a bracket divided to this part, which is 1 plus the cot of theta, which is sine, cos over sine. So remember cot, so it's going to be cos b over the sine of b. That is the idea. So with this, we can simplify, guys, as far as we can, because there we can say that it's a fraction. So 1 is same as 1 over 1, or we can write 1 as a denominator that we are given here, which is cos b. So how can we write 1 as cos b? It is simply the same as cos b over cos b. There's no effect. So with this, we can see that, okay, the denominators are the same. So I'm just going to take it as it is. Then I add the numerators. So it's cos B plus the sine of B. Divided to the same thing here. 1 as the denominator there, it is the sine of B over the sine of B. The denominators are the same. So what do? Add. Sine B, just add the numerators together. So it's going to be sine B plus the cos of B. Okay. There is a division, remember? And remember your fractions. If you have got a single fraction divided to a single fraction, you can introduce multiplication. Invert the second fraction. So meaning to say we are going to have the cos of B plus the sine of B, everything over the cos of B times the sine of B, everything. Sine plus cos is the same as this one. You can even write as the first one the way that it is, or just leave it like that. There's no effect. There's no effect at all. These two are the same. Like I was saying, A plus B is the same, B plus A. So meaning to say you can cancel as long as it is between the numerator and the denominator. So meaning to say we are left with 1 here, we are left with 1. So 1 times the sine of B, that is the sine of B over the cos of B times 1, that is the cos of B. But what is this whole thing combined? Sine over cos. Remember, sine over cos, we took it from a tan. So it can be written as a single trigonometric ratio, which is the tan. And that is the tan of B. And the tan of B, that is exactly what you're given from the right-hand side. And that is exactly what we have. So that is how you can prove identities. Play around with your formulas, whatever that you're given under the trigonometry there. 6.2, without the use of a calculator, calculate the values of beta that will satisfy the following equation. If beta is to be taken in within 0 to 180, reduce each angle in the equation to an acute angle and hence use the trigonometric ratios of, guys, you are not supposed to be told reduce each of these. No. But anyways, that was an advantage. You are told how to answer this question. You are given a question and they're telling you how to answer that question. Okay. Anyways, let's see. 6.2. So there we are given without using a calculator actually. So I'm just going to try and minimize a little bit. So that is the tan of beta is equal to minus, so it was minus the sine of 240 degrees times the tan of 150 degrees, everything over the cos of 300 degrees. So they told us we are supposed to solve for beta, but before that, first reduce these into acute angles, then use special. They are telling you what to do. So we need to reduce this. Remember our trigonometry, I talked about this in our introduction, that we can use the cast concept, where in the first quadrant, if there is a theta, we're going to consider this as a theta. Here it's going to be 180 degrees minus theta, 180 degrees plus theta, 360 degrees minus theta, where theta is the acute angle, where theta is the acute angle, the reference angle. So the question is, where does the 240 degrees lie? In which quadrant does 240 lies? Remember, in terms of angle, this is 0, 90, 180, 270 degrees, 360 degrees. So 240 lies in within 180 to 270 in the third quadrant. And this is the quadrant of 180 plus theta. 180 plus, 180 plus, 180 plus theta, where theta is the acute angle. So the question is, what is the acute angle that was added to 180? So to know that acute angle, simply subtract from 240. 240 minus 180. That is how you can simply know it. That was going to be 60 degrees. Meaning to say, this was supposed to be 180 degrees plus 60 degrees. The 60 degrees is the theta, the acute angle. Remember you said this. So if you reduce now in this quadrant that we are talking about, it's not for sine, it's the quadrant for tan. So the moment you reduce, you must consider that it's for tan, not for sine. So sine there carries a negative. In this quadrant, sine is a negative, so it's minus sine 60 degrees of the acute angle now. Times tan 150. 150 degrees lies in within quadrant. Which quadrant? 90 to 180. It was supposed to be 180 minus theta, which is the acute angle. So 150 from the difference of 180 gives us what? 180 minus 150, there's a difference of 30 degrees. There is a difference of 30 degrees there. So the 30 degrees is the one that you're going to relate. But is it a quadrant for tan? No, this is the quadrant for sine. Meaning to say tan will be a negative. Negative tan 30, the acute angle. 300 degrees, more than 270 degrees, but less than 360, meaning to say you're talking about the fourth quadrant. 360 minus theta. So from that concept, 360 minus 300, there's a difference of 60 degrees. So it's supposed to be a cos. Remember, it's the quadrant for cos there, so it remains as a positive. And use the special angles. They are trying to say, go back to those triangles and so forth. Guys, there's nothing special about those angles, whether you have used your special angles or not. The answers that you have, they are the same. So under exam condition, do not worry about that. Okay, negative here, gonna cancel. So under exam condition, don't worry about that. Once you have reduced, this is the most important stage to reduce like this. From there, you can even use your calculator because the answers are exactly the same. Someone who has used the triangle and someone who knows, because you can even, these ones, you are actually supposed to know them by head. That's the special angle concept. So you can even use a calculator. There's no problem there. Square root of 3 over 2 times the square root of 3 over 3. No one is going to know that you have used a calculator there. Everything over cos of 60 degrees, that was going to give you 1 over 2. From there, it is a simplification throughout. Simplification throughout. Again, you can simplify, guys. This square root of 3 times square root of 3 is going to be 3 over 6, which is a half, minus 3 over 6. That will be a half there. Everything over a half. So as we can see, guys, this was going to cancel, and that will be minus 1 at the end. So that is, we are having a single term, minus 1. These are the stages that we are supposed to have. Use these ratios now to solve. So after this, we must solve for, because the question is, without the use of a calculator, calculate the values of beta The angle now is the one that you need. The angle is the one that you're talking about, beta. So if you are given that the tan of beta, because from this whole thing that we are simplifying, it is representing what? The tan of beta. So if you know that the tan of beta is equal to -1, so what is going to be beta? Remember, you need the reference angle, which we are supposed to write arctan of 1. But there's no arctan of 1, guys. We know that 1, it was taken from 45 degrees. Yes, we can use a calculate arctan of 1, which is 45 degrees. But from there, from our reference angle, from our special angles, tan 45 degrees is the one that gave us 1. So beta is supposed to be at 45 degrees. I mean, the reference angle is supposed to be at 45 degrees. But what is the exact beta now? That is where we consider to say it's a tan, and this tan is a negative. We now take the actual answers of the beta from where tan is negative on these quadrants. In the second, in the third, tan there is negative. So in the second, the answer is supposed to be 180 minus that reference angle, the acute angle. So therefore, beta is 180 minus our reference angle, which is 45 degrees. And that was going to be 135 degrees. So according to the interval that we are given, 360 minus theta is not going to work because we are given that our beta is taken from 0 to 180. In actual sense, we are supposed to have a solution again from 360 minus the reference angle. But we are not going to consider that because of the interval. So the only solution, therefore, that we are going to have for beta was going to be 135 degrees. That is the only solution. Not 45. 45 is a reference angle, like the one that is giving you the direction. The one that is giving you the direction. All right. 6.3. We are given that if the sine of a cos is the same as that of a tan, cos and a tan, they've got same sign, but opposite to the sign of a sine theta. In which quadrant does theta lie? Cos and tan, they are the same. They've got same sign. But they are different to the one of a sine. So from those quadrants, I think I indicated here that all students concept or this cast. So we just need a quadrant where sine and cos, that is tan and cos are the same. Cos theta, tan theta are the same, different to sine. So which quadrant? Okay. In the first quadrant, remember all have got the same sign. So this one is totally out. Let's move on to the second quadrant. The second quadrant, sine is positive, meaning to say tan is negative, cos is negative. In the second quadrant, sine is positive, meaning to say these two are negative. And these two are the same. Sine is on its own. So this is the one that we want. Okay, let's verify with another one. In the third quadrant, it's for tan. Tan is positive. What about cos? Cos here it's negative. Sine here it's negative. This is wrong because they said cos and tan are supposed to be the same sign. Let's check. Tan and cos, they are not of the same sign. So this one is also out. The fourth quadrant is for cos, meaning to say cos is positive. What about tan? It's negative. What about sine? Negative. So this is wrong because cos and tan, they are having different signs, but here we are told that they must have same signs. So this quadrant is also out. So the answer was supposed to be the second quadrant. So in this case, the question was asking you which quadrant. So it was supposed to be the second quadrant. That is the one that fulfills the information that you're given there. 6.4, consider fig B. Below A, B, C are the vertices of a triangle, and we are given angle ABC 30 degrees. All right, and these are the dimensions. Calculate the length of AC. So also you can consider your trigonometry again. Given the cosine rule, you can use that to calculate whenever you are given an included angle. You can use the cosine rule. A there is the included angle, the angle that is found between two given sides. So it is called the included angle. So if you are given an included angle and you want to calculate the side opposite, you can use the cosine rule. And from that cosine rule, we saw that 6.41, we saw that it states that A squared is equal to B squared plus C squared minus 2BC, the cos of A. So that's minus 2BC, cos of A. A squared is the side that you're calculating, which is AC. The B and the C simply means the sides creating the angle that is given. So we've got a 6 and the 4. So you're going to subtract again minus 2 times 6 times 4 times the cos of A. It simply means the included angle, this one, the angle that you're given in between. So there is no need for you to change your formula now because of the sides that you're given. You want to write it in terms of B. No. Know one formula, know what it means. If you know what the formula means, you're not going to have a challenge. Just have to substitute. So this is it. You're going to simplify everything, guys. Here, just use your calculator. You're going to obtain something like 10,431. Then to determine this, introduce the square root to remove the square. So AC is equal to 3,230 meters. All right, remember the dimensions, they are already in meters. So through to 3 decimal places, it was going to be 3.230 meters. 6.42, we are given the magnitude of the angle A. Remember, you just calculated this side, 3.23 meters. So we can calculate the angle A using the sine rule this time. Remember, the sine rule works when you want to calculate an angle given its corresponding side. Given that there's an angle which corresponds to another side, as long as this situation can happen, the sine rule can work. The sine of A over A is equal to the sine of B over B is equal to the sine of C over C. That is the best one to use because you're going to see that. Okay, let me just have it here. That's 6.42. It was going to be the sine of A over A. It is equal to the sine of B over B. That is the sine of the angle A, the sine of angle A that you want to calculate over its corresponding side 4 is equal to the sine of B, which is the one that you're given there, 30 degrees, over its corresponding side. That is the side that we calculated, 3,23. So that's it. Let's solve here. How do we remove this 4? In the denominator, you multiply by it. So to remove the 4 there, you just multiply by 4, multiply by 4. So this can cancel. So it follows that the sine of A is equal to this times 4, which is simply 4 sine 30 degrees over 3,23. So that's it. What we need in this case is to determine the angle A. So it's either you're going to simplify everything that you are given there, that is according to what we have. We can simplify this right-hand side. So you can just try to simplify that. It was going to be 200 over 323. So what I need is the A. So remember how to determine A. You remove that and write it as arcsine on the other side. Angle A is equal to the arcsine of this whole thing that we are saying here. So you can even write it as a decimal. You can write it as a fraction as it is. It's up to you. So arcsine, that is shift sign on your calculator. So you're going to obtain angle A, which is 38,257 degrees to 3 decimal places. That is what you are going to obtain to 3 decimal places. So these can be typical questions that you might be given. All right, consider this fig below. There's a fig C that we are given. That is, okay, something like this. It is actually a graph of f of x, which is equal to a sine bx from 0 to 180, okay? So this is a function of a sine bx from 0 to 180, like the whole interval. Determine the values of a and b, hence write down the equation of the graph. Hence, like after finding a and b, okay? So what is a? Remember, a is the amplitude, which we can take from the minimum to maximum value concept. So a is simply taken from the maximum value minus the minimum value that you are given divided by 2. So you're going to see that a is 4. Maximum minus minimum over 2. Then b from the new amplitude that you are given that we have, okay? Now we consider to say the period that we had before, it was supposed to be 300. This is the graph of a sine, remember. It was supposed to be from 0 to 360 from the normal way that we are used to. But this time, it completes its cycle within, guys, within 180 degrees. So it simply means our B is 2 there. There are 2 cycles. We are supposed to, from 0 to 1, it was supposed to be like this, from 360. But now we are going to complete 2 cycles of that to cover up to 360 degrees. There is another cycle that we have. So there are 2 cycles, 1, 2. So B is going to be 2. Or you can use this concept, the old period, I mean the new period that you are given of 180, this one. The new period is equal to the old period. The old period divided by this B. So the new period is the one that you are given, 180. The old period is the one that we are you guys, the graph of a sine, that is its original period. That period does not change. That is the old period of the graph of a sine, which is at 360 degrees. So it is just like that over B. So you can use this formula if you want. Cross multiply, that will be 180. B is equal to 360. So divide by 180, B was going to be a 2. So B is equal to 2. So after that, the question is not just to find A and B, but also, hence, after that, write down the equation. After that, write down the equation. So therefore, our equation, f of x is equal to A, which is 4. The sine of bx, b, which is 2. So that will be 2x. So this is how it was supposed to be simplified from what we are given. You needed the b from the, you can consider the new period concept or that part that I was explaining, like how many cycles do we have from the old one? How many complete cycles are we going to have from there? Or you can consider the new period is old period over B. Then from there, we can calculate the value of B. So this was our question paper carrying a total of 100 marks. So let us continue, do revise as much questions as we can so that we prepare for our exams, which are ahead of time. But for now, that's it, guys. Till we meet again.